Hi everyone, my name is Nurul Ainfarah binti Yusof. My ID number BMM3521. So for today, I'm going to present an introduction of our lab report.
Hi, welcome back with me, Nurul Ainfarah binti Yusof. My ID number is MA19028. So for the introduction, first we will see as we know, pump are machine that we use to move fluid from an area of low rise to a higher height. And there are different sorts of pump, and we order in two significant classes, which is dynamic or kinetic and also positive displacement. So the background, first pressure. The pressure is an indicator of resistance to flow. The kinetic energy of a fluid emerging from an impeller is real by making a resistance to the flow. The principal obstruction is made by the pump volute, the casing, which gets the fluid and back it off. At the point when the fluid is back down in the pump casing, a portion of the kinetic energy is changed over to pressure energy. It is the resistance from the pump string that is produced on a pressure measure joined to the release line. So next is head. Head is an estimation of the stature of a fluid segment which the pump could make coming about because of the dynamic energy the pump provides for the fluid. The fundamental justification utilizing head rather than pressure to quantify a centrifugal pump's energy is that the pressing factor from a pump will change if the particular gravity of the fluid change. However, the head won't change. So the relationship of head to pressure, since the unit of head is an abbreviate variant of the fluid of flow energy, and since flow energy is equivalent to the fluid pressure duplicate by its particular volume, the pressure comparable to a specific head can be controlled by partition the head by the liquid specific volume. And since specific volume is the corresponding of thickness, separating the head by the particular volume is comparable to duplicating the head by the thickness of the fluid. And the performance characteristic of a pump at a fixed speed are represented by the following graphical relationship. The pressure difference versus discharge. So our problem statement is one of the challenge that pump user face quite frequently comes into play when more than one pump is required to operate at the same time on the same system, which such multiple pump system. There are two arrangements where the operating characteristic of the different pump can be considered to provide a single combined performance curve. So our objective is to determine the pump for performance for single, series, and parallel pump setup. And next is we want to determine the characteristic of centrifugal pump. And next is the result. We want to determine the result on the pressure head, the flow rate, the power consumed, and also the pump efficiency. And lastly, we want to gain some familiarity with the concept of pump curve. So the scope in this report, we focus on the operation of the pump. The first arrangement is a series operation where one pump discharges directly into the suction of the second pump, with both pumps delivering the same flow rate but sharing in the development of the combined pressure. And the next second arrangement is parallel operation, where each of two or more pumps take its suction from a common header and discharge into another common header, thus sharing the flow while operating at the same head. So that's all from me. Thank you.
Hi, my name is Muhammad Aidil bin Jeffrey. number metric MA91025, and I'm from Selangor. And I'm gonna present about theory. A single pump may be insufficient to produce the performance required. Combining two pumps increase the pumping capacity of the system. Two pumps may be connected in series, so that water passes first through one pump and then through the second. When two pumps operate in series, the flow rate is the same as for a single pump, but the total head is increased. The combined pump head capacity curve is found by adding the heads of the single pumps curve at the same capacity. Two pumps may be connected in parallel, so that half the flow passes through one of the pump and the other half through the second pump. When two pumps operate in parallel, the total head increase remains unchanged, but the flow rate is increased. The head capacity curve is found by adding the capacities of the single pump curve at the same head. This is the difference between the series pump and parallel pump. Net head is measure of the pressure experienced by a fluid on the suction side of a centrifugal pump. It is called as head rather than as an actual pressure, because head is a fluid independent property. To calculate the net head, the output power is divided by input power. And the below is the calculation for calculate the net head. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail bin Maliza. My ID number is MA18233 and I'm from Limau, Melaka. I will now start the presentation about the equipment and the procedure for pump series configuration experiment. So for the equipment, we use water tank, control valve, manometer and centrifugal pump. This is a picture of the setup that will be used in our experiment. So for the procedure, for experiment 1, which is a single pump operation, the step 1 is to set the suction valve to a single pump configuration by looking at the picture given. The single pump configuration is which is the only valve 4 and valve number 7 which is set to open and other valve is set to close. Step number 2, both pump will switch on using the main switch. The third step, the volume, flow rate and corresponding pressure will be recorded. And the final step is step 2 and step 3 will be repeated by using a different volume flow rate. For the experiment 2 is series pump operation. Series pump operation quite similar to a single pump operation, but the only change is the valve selection. So for the first step, the valve selection for a series pump configuration is only valve number 4 and valve number 6 will be set to open, and the other valve which is 5 and 7 will set to close. Step number 2, both pump will switch on using the main switch, and the other step which is the step, the volume flow rate and the pressure will be recorded. The last step, the step 2 and step 3 will be repeated using different volume flow rate. For the experiment 3, parallel pump operation, set the suction valve to a parallel pump configuration. Parallel pump configuration is other valve is set to open, and the only valve is set to close is valve number 6. So second step is both pump switch on using the main switch. The volume flow rate and the corresponding pressure will be recorded. And number 4, step 2 until step 3 will be repeated using different flow rate. That's all. Thank you.
Hi, Assalamualaikum. My name is Jamil bin Ahmad Isham from Taiping, Perak. My ID number is MA18235 and I will present about the result and discussion. First, this is the formula used in the calculation to obtain the result and data. There are some assumptions for this experiment. Density of the water is assumed to be exactly 100 kg per meter cube, and the gravity of acceleration is assumed to be 9.81 meter per second square. Pressure in this calculation, that we use data from delivery pressure to obtain the net heat in the experiment for single pump. So this is the formula for the head formula for the single and net head for the series. So for the series pump, the sum of delivery pressure is used to calculate the net head. For the parallel pump, we consider the lowest delivery pressure to calculate the net head for parallel pump. And for horsepower calculation, the calculation is the same for all configuration, single, series, and also for parallel pump. For the result, this is the data for the single pump configuration and the graph of the flow rate against net heat. We obtain the data by using the formula that I explained before. The graph correlation show that pump head decrease as the flow rate increase. This relationship said that the head pump is not proportional to flow rate for a single pump. This is the data for the series pump configuration. And the graph of flow rates against net head. The graph correlation show that pump head decrease as the flow rate increase. This relationship states that the head pump is not proportional to flow rate for a series pump. This is the data for the parallel configuration and the graph of flow rates against net head. The graph correlation show that the pump head decrease as the flow rate increase. This relationship states that the head pump is not proportional to the rate for parallel pump. For the discussion part, there are 3 questions if we refer to the lab sheet provided to us. First question is compare the experiment performance curve to its theoretical curve and describe the discrepancy factor. Based on the experiment performance curve with the theoretical curve, we can conclude that the parallel pump has the highest flow rate compared to the others, while the series pump has the highest head among the others. The result for the experiment curve have a lot of difference compared with the theoretical curve. This is because the loss in pipe and the fluctuation of the flow rate during the process cause an inaccurate of data for the experiment result. Next, from the result obtained, state the use of series and parallel pump. Parallel pump arrangement can increase the flow rate twice for the same head. It can apply to the pump that have a small flow rate for the right head. Parallel pump with variable speed can save energy and introduce significant advance in operation and control. Last is explain why the system with series pump configuration will generate higher pressure than the parallel pump configuration. So the series pump configuration can increase the head twice in the system in the system at the same flow rate, and the pump in series are used to overcome a larger system heat loss than one pump can handle alone. But parallel pump configuration can increase in the flow rate twice for the same heat. Series pump configuration produce twice the heat compared to parallel pump configuration. That makes series pump configuration produce higher pressure. So we conclude that when the net heat increase, the pressure also increase. That's all for me. Thank
Everyone, my name is Arun, matrix ID MA19205, and I am from Kampa Perak. In this video, I'll be presenting chapter 5, which is the conclusion.
Today I'm going to present about chapter 5, which is the conclusion of our experiment 4, which is series and parallel pumps. The main objectives of this experiment are to familiarize with the pump configuration such as single, series and parallel, and to understand the principle and operation and to determine the performance data. These objectives were met after doing the experiment. We already have a background on how pumps such as centrifugal and rotary pumps operate, but in this experiment, there are some variations that the pump was operated in terms of configuration. We were able to familiarize several types of configuration of pumps, which are single configuration, series, and parallel connections. It has a significant application in the industry and power generation. In single configuration, one pump only delivers the fluid from the suction to the discharge. The purpose of setting the pumps in a series configuration is to increase the amount of head of fluid to be delivered following the same amount of discharge for each pump. Parallel configuration, on the other hand, increases the amount of discharge and the amount of head is the same for all pumps connected in parallel. This experiment gives us prior knowledge in order to design whether it is an industrial plant or a power plant. We should consider these types of connections so that the amount of power input will be optimized by following the operation point under the pump characteristics curve. More importantly, the efficiency of the pump indicates that the performance of the pump is considerable in industrial application aside from the condition of the equipment and its operating conditions. That's all from me. Thank you.